Okay, so for this session we'll be multiplying and dividing fractions. Now with dividing fractions, we actually use all the same skills we learned when multiplying fractions, which are these skills here, but there's one thing we have to do when dividing fractions, and we'll look at that when we come to a question with division. So when multiplying fractions, these are the points that you need to remember. Now some of these points were the same ones that we use when adding or subtracting fractions, but a few things are a bit different. And the first point that is different is when multiplying or dividing fractions, you don't need to have the same denominators. So it's very important. We only have to change our denominators to be the same when adding or subtracting. So just remember that. Next point, of course, any mixed fractions, turn them to improper fractions. And then remember that whole numbers are really over an invisible one, because that helps you with your working out. Now, this point here is very important, and I'm going to underline it. And that is, you need to simplify before you multiply. That's an important skill that I need to see that you can do. Yes, you can multiply your top numbers and bottom numbers straight away, but I want to see that you know how to simplify before you multiply. Now to do this, you can simplify anything from the top and bottom. Okay, so you can't simplify two top numbers together. It has to be a number from the top and then the bottom. And this can be vertically, which is straight up and down, or it can be diagonally. So just remember those keywords, and I'll mention them again in the lesson. Once you have simplified, then you multiply the numerators together and the denominators together, and then you'll get your fraction, and your final fraction or answer must be in simplest form. So check and see if you can simplify. And of course, if your answer ends up being an improper fraction, we turn it into a mixed fraction. Okay, so just write down any of these points that you didn't have already, and we'll be going through each of these points with our questions. Okay, with our first question, we have 2 over 3 times 1 over 5. So whenever working with fractions, always check what operation you have so you know what to do. So we don't have to have the same denominators. So 3 and 5 I won't be changing. And the important point was simplify before you multiply. And let's have a look. I have 2 up here. Are there any numbers on the bottom that I can simplify with the 2? I've got a 3 down here. I can't divide 3 by 2. I've got a 5 down here. I can't divide 5 by 2. So I can't simplify my 2 with anything. And I've got a 1 here. And 1, if we divide anything by 1, it stays the same. So with this question, there is nothing that I can simplify. So I can go ahead and simply multiply now my top numbers, my numerators. So 2 times 1 is 2. And multiply our denominators. So 3 times 5 is 15. So you can see how multiplying fractions is different to adding or subtracting. We actually now multiply our denominators, whereas with adding fractions, our denominator, once we made them the same, it stayed the same in our final answer. And that's it, 2 and 15, just do a double check. Can we simplify 2 and 15? No, because 2 divided by 2 is 1, that's fine. But 15 divided by 2, I don't get a whole number, so I stop there. All right, question 2, we are multiplying 3 fractions, but we do the exact same thing. Okay, I can see that I can't simplify anything. I have a 2 on top. Do I have an even number anywhere on the bottom? No, I don't. So I can't simplify anything, so I do the same thing, and that is now multiply the top numbers. 2 times 1 is 2, and 2 times 2 is 4, over, and then 3 times 5 is 15, and 15 times 5 is, I'll just work it out down here. So 15 times 5. So 5 times 5 is 25. Put the 5 down, whoop, and carry the 2. 2 times 5, 2 times 1, sorry, is 5, and 5 plus 2 is 7. So it's 75. Okay, and 4 and 75, can I simplify this any further? No, I can't. And that will be our final answer. Okay, so now let's do some where we have to simplify before we multiply. Okay, with question 3, now we can see that I've got a 2 on top and a 4 on the bottom, and straight away I know I can simplify this fraction. 2 over 4, it's the same as a half. And I can also simplify my 3 and 9. And we can see we are simplifying vertically, which is straight up and down. I can't simplify diagonally with this one because 2 and 9, can I divide 9 by 2? No. And with my 4 and 3, can I divide 4 by 3? No, I can't. So I'm stuck simplifying only vertically, straight up and down. And it's something from the top and something from the bottom. So I'll simplify this fraction here first. I can see a common factor is 2, so divide them both by 2. And of course, what we do to the top, we must do to the bottom and the other way around. And here, I know 3 is a factor of 3 and 9, so I'll divide 3 by 3. And that little dot is not working. There we go. And I'll divide 9 by 3. Okay, and please, when you're doing this on a test or an exam, show this working out so I know you're dividing by the same number. Okay, and 2 divided by 2 is 1. 4 divided by 2 is 2. I've got a times here. 3 divided by 3 is 1. And 9 divided by 3 is 3. And now there is nothing else I can simplify. So now I'll just multiply my top numbers together. So 1 times 1 is 1 over 2 times 3 is 6. And that's my fraction. And just remember that 1 does not become invisible because it's on top. If I had 6 over 1, then it is really 6. That can become invisible. But 1 over 6 is completely different to 6 over 1. So just remember that. Okay, so if you want to try this question before I do it, go ahead. Now, with this question, let's check and see if I can simplify anything from the top and bottom. And I have a look, and I look at my 2 and 3. I can't simplify 2 and 3, and I can't simplify 9 and 4. So I can't simplify vertically. What about diagonally? So diagonally means not vertically, that's vertical. This one is horizontal, and we cannot simplify horizontally. I can't simplify my 2 and 9 or 3 and 4. We can't do that at all. But we can simplify diagonally, and that means diagonal. And to remember what diagonal is, have a look at your multiplication sign. One line is going that way, that's diagonal, and the other one is going that way. Okay, these two lines are both diagonal. And what you can do is, if you want to put arrows to remind you that you can simplify 3 and 9 and 2 and 4, just to remind you, then you can do that. This one actually works perfectly for this question because that's what I can simplify. I can simplify my 2 and my 4 and then my 3 and my 9. And remember, number from the top, a number from the bottom. So if I divide this 2 by 2, I must divide this 4 by 2 because we must do the same thing to the top and the bottom. And then this 3, if I divide it by 3 on the bottom, I must divide the top by 3, and here's my number that I'm dividing by because it divides evenly. So 9 divided by 3. And now let's write our new fractions. We've got 2 divided by 2, which is 1. 3 divided by 3, which is 1 as well, times 9 divided by 3, which is 3, and 4 divided by 2, which is 2. Okay, now we multiply our fractions out, and you can see that we'll end up with this fraction here because 1 times 3 is 3, and 1 times 2 is 2. And we're almost there, and of course, we can see we have an improper fraction. The 3 is bigger and it's on top. So my final answer should be, how many times does 2 fit into 3? Well, I know it fits in once. Remainder 1 over, we keep the same denominator over 2. So my answer was 1/2, 1.5. Okay, let's try our next question. Okay, for question 5, I can see that I have a 10 up here and a 10 down there, and also a 20 up there and a 20 down there. And the trick is, if you see the same number on top and on bottom, you can just cross them off. That's a fast trick. And that's because we're actually, by crossing it off, we're saying 10 divided by 10 is 1, and 10 divided by 10 is 1. And the same with the 20s. I can go 20 divided by 20 is 1, and 20 divided by 20 is 1. Or the shortcut is, if you see the same number on top and on the bottom, just cross it off. And what are we left with? Well, I can see my answer is going to be 1. or 1 over 1, which equals 1, because 1 divided by 1 is just 1. And that's it. That was a nice and easy one. Let's try question 6. Okay, question 6, let's have a look and see what we have. I have 24 over 25 and then 100 over 100. Now, remember that trick? If you see the same number on top and on the bottom, you can just cross them off. But if you decided to divide the 25 by 25 and the 100 by 25, you could also do that. But I think the best and fastest way is to cross off the 100 on top and cross it off on the bottom, which is really dividing by 100 and dividing by 100, and we get 1. And we're left with 24 over 25. Now, can I simplify 24 and 25? Is there a factor that will go onto both? No, there isn't. I can't divide them by 2 because 25 is not even. So I'm left with 24 over 25 because 24 times 1 is 24 and 25 times 1 is 25. And that's our answer. There is nothing else we can do. Now, number 7 is starting to get more challenging only because we now have 3 fractions instead of 2, but this is just as easy as the other ones. And we apply the same rule. Simplify anything from the top and anything from the bottom. And this means you can actually skip fractions. So, for example, see how I have a 20 up here and a 20 down there, and we know we can just cross them off. Because they're far away from each other, it doesn't matter. As long as you have a 20 on top and a 20 on the bottom, we can do that. Cross off that 20 and cross off that 20, or divide them by 20, and we have a 1. And that can work. And have a look at this. I've got a 5 on top and a 5 on the bottom. Let's cross that off. Divided by 5, it's 1. Divided by 5, it's 1. And also a 7 and a 7. Divided by 7, it's 1. And what's my answer? Well, my answer will be 1 times 1 times 1, which is 1, over 1 times 1 times 1, which is 1, and 1 divided by 1 is 1. And that's how easy that question was. So this one shows us that I could simplify my 20 all the way on this side with this 20, which is all the way over here. Okay, so you can actually skip fractions. That's fine, as long as it's a fraction on top and the bottom. Now, this one here is another tricky or more challenging one, but let's have a go anyway. So, let's see what I can simplify from the top and bottom. I've got a 20 up here and a 40 down there. Another trick that I know is if I see a 0 on top and on the bottom, I can cross off my 0 and 0. And what really happened was I just divided by 10. Dividing by 10 means you can just chop off a 0. Okay, so I'm left with 2 over 4. Let's keep going. Oh, look, I can see a 6 up here and a 6 down there. That can go. It's a 1. 6 divided by 6 is 1. What else can I do? Oh, I've got a 5 and 25. I can divide 5 by 5 and I can divide 25 by 5. Top and bottom, that's a 1. 25 divided by 5 is 5. Now, my working out is starting to get a little bit messy, so I'm going to rewrite my fraction. So I've got 2 over 4 left. So please make sure you be careful not to leave a number out. I've got a 1 over 1, which I didn't actually have to write. And I have a 1 over here over 5. Now, I can multiply these out because I have done a pretty good job in simplifying, but guess what? I can see a 2 on top and a 4. That means I can divide 2 and 4 by a common factor of 2. So 2 divided by 2 and 4 divided by 2, I'm left with 1, and 4 divided by 2 is 2. So finally, I have completely simplified this problem, and I've ended up with these 3 fractions, and now I multiply numerators, so my top numbers together, and then my bottom numbers together. So 1 times 1 times 1 on top is just 1, 2 times 1 is 2, and 2 times 5 is 10, and there is my final answer. So you can see that even if I had 10 fractions I was multiplying together, that would still be just as easy because you simplify anything from the top and bottom, and that's it. Now, with question 9, this is where we have a whole number, 2, and I know that whole number is really over a 1, okay? That's invisible. But before we work it out mathematically, I want you to understand what we mean by this question. What's actually happening? We're saying 2 halves, because this symbol here, times or multiplication, it actually means groups of. Groups of, or sometimes it can just mean of, and that's why of in maths means times. And in this problem here, we're saying two groups of halves, or another way that makes more sense is we're saying two halves. If I have two halves, so there's one half of a pizza and another half of a pizza. If I have two halves of a pizza, how many pizzas do I have? I know I end up with one whole pizza that's cut in half. So I expect my answer to equal 1. That's what's actually happening. Now let's work this out mathematically and see if we get a 1. So I'll write it down here again. 2 over 1 times 1 over 2. And remember, I put this 1 here just for me to, just so it can help me with my working out. Simplify before we multiply. 2 on top, 2 on the bottom, same number. Let's just cross it off or divide by 2, which gives us 1. And we end up with 1 times 1 is 1 over 1 times 1 is 1. And 1 divided by 1 is, so it's a funny equal sign, is just 1. And I can see I got my 1 whole pizza. Let's try another question that's quite similar to the other one. This is saying 4 groups of halves, or we can just say 4 halves. If I have 4 halves, let's work out this answer without even doing any mathematical working out. 4 halves, 1, 2, 3, 4. How many whole pizzas do I have? 1 and 2. So I know this question will equal 2. Now let's do it mathematically to see if I get the right answer. That 4 is really over a 1 times 1 over 2. Simplify before we multiply. I've got a 4 on top and a 2 on the bottom. I can divide this 2 by 2 and divide that 4 by 2. What I do to the bottom, I must do to the top. 2 divided by 2 is 1. 4 divided by 2 is 2. So I'm left with 2 times 1 is 2 over 1 times 1 is 1, which equals 2. And I got my 2 whole pizzas. Now, I think we're up to question 11. I forgot what number I was up to, so I am sorry if I'm forgetting my numbers. But anyway, now have a look at this. We have 2, what kind of fractions are these? They are mixed fractions. And whenever we see mixed fractions, before we do anything, we turn them into improper. And we do this whenever we work with fractions, whether we're, that's the times, whether we're adding, subtracting, multiplying, or dividing fractions. If you see a mixed fraction, you turn it into an improper fraction. Okay, and I know how to do this. 2 times 2 is 4. 4 plus 1 is 5. And we keep the same denominator, which is 2 over there. Times 2 times 5 is 10. And 10 plus 1 is 11 over 2. Now, let's see my fractions. Can I simplify anything before I multiply? No, I can't. My 5 and 2 I can't simplify. My 2 and 11 I can't. My 5 and 2 I can't. And my 11 and 2 I can't. They're all my options. I can't simplify anything, so I'll just multiply it out. 5 times 11, that is 55. Over 2 times 2 is 4. And now, how many times can 4 fit into 55? If you've forgotten your 4 timetables, we can actually start this by dividing. So this falls down under the bridge. This might help you to calculate when you have large numbers. And how many times can 4 fit into 5? Well, 4 can fit into 5 once, remainder 1. 4 into 15, that can fit 4, 8, 12, that can fit 3 times. And now we don't have to write the decimal. I can see 4 fits into 55 13 times perfectly. So there's my big 13. And if I'm at 12, so 4 into 15, 4 times 3, so that was 12. So what's my leftover? What's my remainder to get to 15? So 12, 13, 14, 15. I had a remainder of 3 over, keep your same denominator, over 4. Okay? And you could have done this one, it wasn't too much of a big number, because I know that, let's see, 4 times 13 is 52. so that it can fit in 13 times, and 52, yep, 3 over 4. So I'm just double checking and I have the right answer. So when you have large numbers, set it up like you'll be dividing as normally. And then 4 into 5 goes once, remainder 1. 4 into 15 can go 3 times, because 3 times 4 is 12. Put the 3 there. But now, instead of getting your decimal ready and adding some zeros, we're not turning this fraction into a decimal. We're leaving it in fraction form. Okay, so instead of putting the remainder on the 0, and we got 4 into 30, we stop, get this remainder, and put it over that 4. So that's a way you can turn an improper fraction that's getting a bit larger and trickier into a mixed fraction. Have a look at this fraction and see what operation you see in between these two fractions. What's this symbol here? It is division. So now, with division, when dividing fractions, you just have to remember one important point, and that is we have to turn division into multiplication, into times. So we've got to turn this into times and then simplify my fractions before I multiply. Now, how do we turn division into times? It's really, really easy. I call it the flip trick, and that is you have to flip not the first fraction, but your second fraction, so the one on the right-hand side. You need to flip the 3 and 2 over, and then you turn division into times. This half is staying the same, so I have 1 over 2. Instead of division now, I'm going to write times because I flipped my 3 and 2, and I now have 2 over 3. And now look at this. We can work with multiplying fractions. We have learned all of these skills already. All I got to do is simplify before I multiply. So my 2 and 2 on top and bottom, that can go. And I'm left with 1 over 1 and 1 over 3. So times 1 over 3. Which equals 1 times 1 is 1 over 1 times 3 is 3. And there's my answer. So when dividing fractions, just remember we turn division to times by flipping our second fraction. So write that down if you haven't got it already. Let's try another one. This one here, we can see we have division. So we need to turn division into times. So a trick is just circle your division to remind yourself we have to change it to times. And to do that, we must flip the 9 and 10. So put these arrows there if it helps you. So now 3 over 5 stays the same. I now have times because I flipped my 9 and 10, and I now have 10 over 9. And now let's simplify before we multiply. I can simplify my 3 and 9, divide 3 by 3 and divide 9 by 3. That leaves me with a 1, and that leaves me with a 3. And have a look, 10 and 5, perfect. I can divide 5 by 5, and I can divide 10 by 5. That's a 1, and 10 divided by 5 is 2. And what we have left is 1 over 1 times 2 over 3, which equals 1 times 2 is 2, 1 times 1 is 3, and that's our final answer. I can't simplify this fraction anymore, and it's a proper fraction. Now, our last question for this session, sorry, I've just made a mistake. That's supposed to be division, and we're going to turn it into times. Sorry. So I have 9 over 11 divided by 9. And you might think, how do I flip this? I've got it, so we know we have to turn division to times. So yeah, we circle this, got to change it to times. But I have to flip my 9 with what? What do I flip 9 with if I just have a 9? Remember, that 9 is really sitting on top of an invisible 1. So I flip my 9 and 1. So I'll be left with 9 over 11 stays the same. I've changed division to times. I flip this, so I end up with 1 over 9. And now, easy. We simplify before we multiply. So 9 and 9, same number, chop it off. It's gone. Or we have a 1 because we divided by 9. And now, what do we have left? Well, 1 times 1 is 1 over 11 times 1 is 11. and there's my answer. Okay, so keep practicing questions involving multiplication and division, and remember, practice makes perfect.